Good day, grade 12 learners. Welcome to today's subject lesson. My name is Sibusiso Shongwe. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Right, we have our WhatsApp interactive number, which is 064 748 8913. 064 748 8913. Right, today's lesson is a continuation from last week's lesson. I would say it would stand on the shoulders of last week's lesson on analytical geometry, where you did grade 10 and 11 revision of concepts. So today we're going to focus mainly on circles. What we're going to do is we're going to look at all the concepts that we need for answering exam papers in circles. And then through the use of last week's concepts and this week's concepts, then you'll be able to answer exam papers. Right, to begin with, let's look at our objectives for today. By the end of today's lesson, you should be able to determine the equation of a circle with the center at the origin. Determine the equation of a circle with a center at any point labeled A, B. Determine the equation of a circle with center labeled AB if the equation is not given in standard form. Determine the equation of the tangent to a circle. Determine the length of a tangent to a circle. Determine whether the point lies inside, outside, or on the circumference of the circle. Determine the relationship between circles, whether you have circles intersecting internally, externally, or whether they do not intersect. Analyze an important relationship between a circle and a line. Obviously, we can refer to a CAPS document on page 47, as well as the exam guideline that was published in 2021 on page 8. Right, for us to then continue with the lesson, we need to ensure that we know these basic grade 10 and 11 concepts. Number one, using the distance formula to perform calculations, the midpoint of a line segment, the gradient of a line, parallel lines, perpendicular lines, and collinear points, the angle of inclination, the equation of a straight line, properties of quadrilaterals, as well as properties of triangles. Right, we need this important terminology about circles that would be very, very useful in this section of work. The diameter is twice the radius. The center becomes the midpoint. Since you know the formula of determining the midpoint from grade 11, you can use that formula if you are given the endpoints of a diameter. The radius is the same throughout the circle. The tangent is perpendicular to the radius or to the diameter. The normal line is perpendicular to the tangent at a point of contact, and the normal line is not necessarily the radius or the diameter, but can go through the circle, be it outside or inside the circle. A secant cuts the circle twice. The chord touches the circle twice internally and divides the circle into two segments. That would be the minor segment and the major segment. A chord divides the circle's circumference into the different arcs. A circumference is the distance around the circle. Right, these are parts of a circle. You can check there, you have your minor segment as well as the major segment. You have the radius labeled OB, You have the minor arc labeled AB. You have the diameter labeled AC. You have a major segment. You have a minor arc. And you have a sector, BOC. Those are parts of the circle that are important to know. Right, moving on. There's a relationship that exists between a circle and a line. This relationship would be tested later in the lesson through calculations. But for now, what we should know is that if we have a line that touches the circle at two distinct points, we call that line a secant. If we have a line that touches a circle at one point externally, then that line is a tangent to the circle. And if a line does not touch the circle, then that should be an exterior line. Obviously, we'll use some algebraic properties here to be able to identify whether a line is a secant, a tangent, or an exterior line. What we're basically going to use is a simultaneous equation, and then from there we're going to check the solutions that we get. If we get two roots, it means that we'll have 2 points of intersections, which would mean that the line would touch the circle 2 distinct points. Then the line would be a secant. However, if we find that there is one root and hence 1 point of intersection, then would obviously conclude that that particular line touches the circle externally at 1 point, and hence the line should be a tangent. However, if we also work out the roots and we find that the roots are non-real or imaginary, then it will mean that we won't have any points of intersection, and hence the line becomes an exterior line. Right, moving on. The equation of a circle that is centered at the origin. Now, an imaginary circle can be drawn here. If it is centered at the origin, then the center there is given by 0:0. The abscissa is 0 and the ordinate is 0 as well. That is the first circle that we're going to look at, the one that is centered at the origin, or the one whose center is at the origin. Right, through example 1, they ask us to determine the equation of a circle with a center at the origin and a radius of square root 10 units. Now, if a circle is centered at the origin, then its governing equation in this case would be x squared plus y squared equals r squared. Now, in this case, we are given the radius, which means that we have to substitute square root 10 where r is, and hence this would be x squared plus y squared is equals to square root 10 squared. Now, through simplification, we get that x squared plus y squared becomes 10. Now, that would be the equation of a circle. X squared plus y squared is equals to 10, because this circle is centered at the origin. Now, moving on to the second example, we are now not given the radius of a circle, but however, we're given the point through which the circle passes through. So we are given the point with the x value -3 and the y value 4. We say in this case the abscissa is -3 and the ordinate is 4, and hence the set of ordered pairs, which is the coordinate of this point, would be -3:4. Now, for this one, the equation of the circle would be x squared plus y squared equals to r squared. And then from there, since we are given x is -3, we're going to put -3 where we see x and square the value, and put 4 where we see y and square the value. That should be given by r squared. Now, if you simplify, -3 squared becomes 9. 4 squared becomes 16, and the sum thereof becomes 25. So r squared becomes 25, and hence the equation would be x squared plus y squared is equals to 25. That's the equation of the circle that is centered at the origin. If you can look at these examples, grade 12s, in the first example, you were exclusively given the radius, which means that you would substitute the value of the radius where you see r in the original equation, and hence work out the equation of the circle. However, in the second equation, you are given a set of ordered pairs. You are given the abscissa, the x value, and the ordinate, the y value, which you can then substitute into the original circle equation and be able to then calculate the value of r. After calculating r, then you go back and substitute it in the original equation to get the equation of that particular circle. Right, moving on. Example 2, it's an equation of a circle with any point marked A is to B. Now, in this case, grade 12, what happens is we have the circle that is centered around the origin, and then we're going to move that circle by A units to the left or to the right, and move the circle by B units up or down. Now, in that case, it means that all the points of that particular circle are going to be transformed by A units horizontally and B units vertically, which means that if we can apply the transformation to the original equation. Now, the original equation, we know it's given by x squared plus y squared becomes r squared. That is if it is centered at the origin 0 is to 0. However, if we apply that particular transformation, you can see that now, if all the x values are transformed by A units horizontally, then it means that the new point x would be x minus A all squared, and y, all the y values would move B units vertically, which would be y minus B all squared. This will then simplify to r squared. The radius remains the same because the radius, remember, it's the point from the center of the circle to its circumference. Irrespective of how you move the circle, the radius of that particular circle remains the same. Hence, we did not apply the transformation on the value of r. Now, we can see that now that everything has moved A units horizontally and B units vertically, then the center 0 is to 0 as well will move A units horizontally and B units vertically, which means that the new center will then be given by the set of ordered pairs, x being A and y being B. That is the transformation that we have then applied to then obtain a new equation of a circle. Now we're going to use that particular equation to answer or to respond to example 2. In example 2, we are given that we are asked to determine the equation of a circle with a center 1 is to minus 3 and a radius of 2 units. Now you can see that the center is no longer 0 is to 0, which shows that this circle is not this circle is not centered at the origin, but it is centered at a new point 1 is to minus 3, which means there was that transformation of 1 unit horizontally and 3 units vertically. Now, because of that, everything else changes. Now, let's look at how we can solve this one. Obviously, the new equation now is x minus A all squared plus y minus B all squared is equals to r squared. That's the new equation, the one where we've applied the transformation A is to B. Now, in this case, you are given the center, which means that you have the value of A, x minus 1 all squared, and you have the value of B, y minus 3 all squared is equals to, you are given the radius is 2 units. So this would be then 2 squared. Now moving on with this, if we simplify, this obviously would be x minus 1 all squared plus y plus 3 all squared is equals to 4. So this would be the equation of that particular circle that is centered at 1 is to minus 3. Now moving on to the second problem. The center in this case is minus 1 is to 3. And instead of being given the radius grade 12s, we are not given the radius in this case. We are given as well a point minus 4 is to minus 1. So in this case, we're still going to rewrite the equation of the circle. Y minus b all squared is equals to r squared. Now, we will then substitute the center, which is given by minus 1 as well as 3. After substituting the center, then we check we are given a point minus 4 is to minus 1. So x in this case is minus 4 and y is minus 1. So we're going to substitute where we see x, we put minus 4, and where we see y, we put minus 1. And hence we'll be able to work out the value of r squared. So we substitute where we see x, we put minus 4. So this would be minus 4 plus 1 all squared plus where we see y, we put minus 1 minus 3 all squared. This should give us the value of r squared. If we continue this side, we're going to obtain that now minus 4 plus 1 all squared, that would be minus 3 plus 1. Oh, minus 4 plus 1, it will be minus 3 squared. That should be 9. Plus minus 1 minus 3, that would be minus 4 squared, which would be 16. That would be r squared. So r squared is given by 25, which means that the equation of that particular circle will then be x plus 1 all squared plus y minus 3 all squared is equals to 25. Now that would be the equation of a circle. You can see also in this case we are given the center as well as the radius in the first question. In the second question, we're given the center as well as an additional point. Now moving on. Now we move on to an equation of a circle that is not in standard form. In this case, we are given an equation x squared plus y squared plus ax plus by plus c is equals to 0. Now in this form, we cannot directly pick up the center of the circle as well as its radius exclusively from the given equation. In this case, grade 12, we need to go back to our grade 11 knowledge of the completion of a square to then work out the new equation, or to transform this equation into the equation with a center and the radius, which is now in standard form. Now, how are we then going to complete the square? The only difference here is that you are completing the square twice. You're doing so for x and you are also doing so for y, as opposed to in grade 11 where you only completed the square for x and hence worked out the equation of the turning point of a second degree function or a parabola. Right. Now, in this case, in order for us to complete the square, we need to understand the following steps. First step is you rearrange whatever that is given, or the equation that is given, in descending order of the leading variable. Say for an example, if you are given x squared plus y squared plus ax plus by, you're going to group those the terms that contain x on their own in descending order, which means you start with the highest degree going down, and then you group the ones that contain y, and then you move the constant to the right hand side, or you transpose the constant to the right hand side. Now what we do is we check the value of b within the first set of equation, and then from there we complete the square for that, we go back to the second part. We complete the square for y as well. Obviously, to complete the square, we take half the value of b and square the result. But now, what you do on the left should also be done on the right. Whatever that was added on the left-hand side should be added on the right-hand side as well. Now, the last step in this case would be to then factorize. All right, let's use whatever notes that we just went through so that we solve maths problems. We'll do that through example 3. If you check grade 12 in example 3, we are given the equation, and this equation that is given is not in standard form. And hence, we are required to then complete the square to convert the equation to center and radius form. Now, the question reads, determine the coordinates of the center and the length of the radius of the following circle. You're given x squared plus y squared minus 8x minus 2y minus 20 is equals to 0. First things first, we are going to group values that contain x in descending order of the variable, meaning we start with the highest power of x. In this case, it would be x squared. That should be followed by minus 8x. Moving on, grouping the y's, this would be y squared minus 2y. There was a constant 20, which will then be transposed to the right-hand side and then would obtain positive 20. Now we're going to complete the square for x first. How are we going to do that? We're going to go back and say if the standard form of that equation was a1 x squared plus bx plus c, then we're going to take the coefficient of x, which is b. We take b over 2 and then we square. That is what we should then do for this particular problem. Now, the value of b in this case is minus 8. So we're going to then take minus 8 and then we square. So this would be x squared minus 8x plus, we are going to take minus 8 over 2 and then we square the result. On the right hand side, we should obviously do the same. We had 20, then we should have minus 8 over 2 and then we square. So what I added on the left, I added on the right hand side as well. Now moving on to the y values, we're going to then take, this is y squared minus 2y. The value of b in this case is minus 2. So we're going to take minus 2 over 2 and we square. We do the same on the right hand side. We add minus 2 over 2 and then we square. So that is basically grade 12's how we complete the square. And now we're going to simplify. Simplifying this, we obtain x squared minus 8x minus 8 over 2 gives us minus 4. Minus 4 squared gives us positive 16. Plus y squared minus 2y plus minus 2 over 2. This gives us a minus 1. Minus 1 squared gives us positive 1. This would be equals to, on the right hand side, you would have 20 plus 16 plus 1. Simplifying this further, we can then factorize this part for x, factorize this part for y, and then work out what we'll obtain on the right hand side, or whatever value that we obtain on the right hand side. Now, to complete the square for this one, we're obviously going to take now the square root of the first term, that should be x. We take the sign of the middle term, that is minus, and then we take the square root of the last term, That is 16, which means the square root thereof would be 4. And then we square the result. So we factorize the first one. We've completed that particular square plus. Now for the y values, we take the square root of the first term, the leading variable, that is y. Take the sign of the middle term, minus. Then we take the square root of the last term. In this case, it's 1. The square root of 1 becomes 1. Then we square the result. And then this would be equals to. On the right-hand side, we add 20 plus 16 plus 1. That should be 36 plus 1, which is 37. Now we've converted that equation into a standard equation. Now from here, we can be able to take out the center and the radius. The center in this case would be given by 4:1, and then the radius would be given by the square root of 37. Why is it given by the square root of 37? Remember, r squared is equals to 37. So if we take the square root both sides, and then we're going to have that it's the square root of 37. Remember, for any second degree equation, you should be getting two roots. In this case, it was supposed to be plus minus the square root of 37. However, the radius cannot be negative because this is just a distance, and distance is never negative. As a result, we're only going to take the positive root to get the radius. Right, that is how we complete the square. Let's review what we did. We isolated the x values, isolated the y values, moved the constant to the right-hand side by transposing it, and then we completed the square for x, complete the square for y, and work out the radius. And then from there, we can be able to get the equation into the center and radius form, which means we'll be able to pick up now the center as well as the radius from the equation. Right, moving on, grade 12. I have now an activity for you. Similar to the example that I just did, you are required to determine the coordinates of the center and the length of the radius of this particular circle. Now, grade 12, please follow the steps that I've given you to work out the center as well as the radius of this particular circle. I'm going to give you 3 minutes to work that out, and your time starts now. Welcome back. Right, I gave you a problem where you need to work out the center and the radius of this particular circle. Now I want to do the problem with you and see whether you were able to do it correctly. Remember the steps: isolate the x values from the y values, and then complete the square for x, complete the square for y. Make sure that the constant has been moved to the right hand side. Whatever you add to complete the square for x should be added as well to the right hand side. Whatever you add to complete the square for the y should also be added to the right hand side. Right, let's go through this problem. Now, if you check this problem, we are given x squared plus y squared minus 6y minus 55 is equals to 0. Now, if you check the leading variable x squared, if you are to isolate this, we don't have the middle term, or rather the bx term for x, which means that this should be left as it is. Then for y, we have y squared minus 6y. We move the constant to the right hand side, we get 55. Now, because of this, you can see that the square for x, or rather x is already squared. There is no need for us to complete the square for this one because we don't have the bx value, or we don't have the value of b, which we can divide by 2 and square. So we'd leave this as it is. And then for y, we obviously have to then take the value of b divided by 2. In this case, the value of b is minus 6. If we divide minus 6 by 2 and we square, we're going to get minus 6 divided by 2, which is minus 3, all squared. That should give us positive 9. So as a result, we're going to then add 9 on the left-hand side and add 9 on the right-hand side. Now, by so doing, we still leave the x squared as it is, and then we're going to complete the square for y. Now, in completing the square for y, told you first things first, you take the leading variable, you take the square root of y squared, you get y. Take the sign of the middle term, that is minus. Then you take the square root of the last term, in this case would be 9. Should be the square root thereof would be 3, all squared. After squaring that, then on the right hand side you have 55 plus 9. If you add 55 and 9 using your calculators, you're going to get that this is 64. Now you've worked out the equation of the circle. However, the question said you need to work out the center and the length of the radius. So in this case, the center would be, the x value would be 0. The transformation there is 0. The transformation for the y is 3. And r should be given by the square root of 64. The square root of 64 in this case would be 8. So we've successfully converted the equation to the center and radius form. Grade 12, you should note that it's not always the case that the leading variables for x and y would have a coefficient of 1. Sometimes the equation can be multiplied by a constant factor. Say, for an example, if an equation is multiplied by a constant factor of 2, for an example, we take the equation that we have in activity 3. If you multiply that by a constant factor of 2, you're going to get that this is 2x squared plus 2y squared minus 12y minus 110 is equals to 0. You can obviously be asked to convert this equation to the center and radius form. If you check the leading variables, both of them are multiplied by a constant factor of 2, which means that before we start, we need to divide everything by 2 so that the leading variables have the coefficient of 1. That's very, very important. It's not always the case that the leading variables for x and y will always be 1. Sometimes you'll get the equation that has been multiplied by a factor, which means that you have to uniformly divide out by that particular factor before you start completing the square. Right. Moving on. Now, I have a challenge question here that I want to take you through. In this challenge question, you are given an equation of a circle. However, there are variables there, that is variable k. And in the first question, we are required to express the radius in terms of k. And in the second question, we are required to work out the coordinates of the center. Right, I'm going to lead you through this challenge question. Right, if you look at the equation is not given in standard form, which means that we have to complete the square to standardize this equation. Now, which means we have to follow the steps that we went through of completing the square. Now, obviously, we want to then isolate the x values, that is 2kx, isolate the y values. We are fortunate in this case that they've been isolated for us. Ours is just to move the constant to the right hand side. And in this case, the constant is plus 4. Transposing it gives us minus 4. Right now, we need to complete the square for x. Obviously, through completion of the square for x, we need to take the coefficient of x. In this case, the coefficient of x is 2k. So we're going to take 2k divided by 2, and then we square the result. That should give us k squared. As a result, this would be x squared plus 2kx plus k squared. Obviously, we know that what we added on the left should also be added on the right. That would be k squared as well. Now, we've worked out the factor for the first leading variable x squared, or the first part that is governed by the variable x. Now we move on to the one that is governed by the variable y. In this case, what we're going to do is we rewrite this y squared minus 6y. Now the value of b in this case is minus 6. So we need to take minus 6 divided by 2, and then we square the result. So we're going to then have minus 6 divided by 2. If we square the result, minus 6 divided by 2, that's minus 3. Squaring the result in this case would then give us a value 9. So we're going to then add 9 on the left and add 9 on the right. Now moving on, we've isolated, we've worked out the factors. Now we need to then factorize. We factorize for x. How do we do that? We take the square root of the leading variable x squared, take the sign of the middle term, take the square root of the last variable, in this case would be k squared. So we take the square root of x squared, that is x. We take the sign of the middle term, that is plus, and then we take the square root of the last term, in this case is k, and then we square the result. Moving on. For y, we're going to take the square root of the first term, that is y, and then we take the sign of the middle term. In this case, the middle term is minus, or it's negative, so this would be minus. We take the square root of the last term, in this case it's 9, the square root of 9 becomes 3, and we square the result. This would be given by, in this case, we would have minus 4 plus 9 plus k, minus 4 plus 9 plus k. So we'll get that our k squared, if we simplify, this would be k squared plus 5. So we obtain k squared plus 5. So that would be the equation. However, the question said express the radius of the circle in terms of k, which means that now we want to work out the radius, and in order for us to get the value of the radius, obviously we know that r squared is given by k squared plus 5, which means that r is the square root of k squared plus 5. So we were able to work out the radius in terms of k. Now moving on to the next question. If the radius is given as 3 and k is less than 0, determine the coordinates of the center. So we'll complete this problem in the next slide. Oh, we need to then try to make space here because I don't have another space. Now, what we're going to do is, since we are given that the radius is 3, which means that where we see r, we're going to put 3, which means that we'll have 3 is equals to the square root of k squared plus 5. 3 is equals to the square root of k squared plus 5. Now, we want to simplify this. This is a third equation. Obviously, in grade 11, you learned that if you have a third equation, you need to square the left-hand side and square the right-hand side after the sets have been isolated. Now, we have that this set have been isolated, so we square the left-hand side. If we square the left-hand side, we get 9. If we square the right-hand side, we get k squared plus 5. If we simplify this, we get that k squared is equals to 9 minus 5, that's 4, which means that k would be plus minus the root of 4, k would be 2, or k would be minus 2 in this case. Now, if you check from the question, they said k is less than 0. So it means that we're going to discard k is equals to 2, because k is equals to 2 is positive. This here just means k less than 0 just means you take the value of k that is negative, because less than 0 are values that are negative. So it means that we should be taking k is equals to minus 2. So they said we need to determine the coordinates of the center. Now, if you check the original equation, it contained values of k. So the original equation, where we see k, we're then going to put minus 2. So this would be x minus 2, taking it from this original equation, x minus 2 all squared plus y minus 3 all squared. This would be equals to k. In this case, it's minus 2 squared plus 5. Now, they just wanted the center. We can take the center from the equation. Our center in this case would simplify to 2 is to 3. So that would be the solution set to our challenge question. Right, moving on. Now, we move on to a new concept, the equation of a tangent to a circle. In Euclidean geometry, you did work with tangents when you were doing your cycle geometry, and you know that the tangent is perpendicular to the radius. However, because this is coordinate geometry, we work with algebraic properties of circles as well as tangents, which means that we have to then zoom into the algebraic properties that we know. Since the tangent is perpendicular to the radius, from grade 11, you know that if two lines are perpendicular, then the product of their gradients should give you minus 1. In this case, you have a tangent to that particular circle, which means that the radius of that particular circle as well as the tangent are perpendicular to each other. And if they are perpendicular through the properties of gradients, you know that the gradient of the radius times the gradient of a tangent should give us minus 1. So now, in this case, you need to follow the following steps. Determine the gradient of the radius at the point of contact. Since you'll be given the point of contact, you need to then determine the gradient of the radius. So you'll be taking the center, xy, and you'll be taking the point of contact. If the point of contact is P, x at P, y at P. So you work out the gradient of that particular radius. After that, you use the property that the gradient of the radius times the gradient of the tangent is minus 1. That would then give you the gradient of the tangent, which means that the gradient of the tangent in this case would be -1 divided by the gradient of the radius. After working out the gradient of the radius, since you need an equation, we know that we can use y minus y1 is equals to m into x minus x1. And remember, we need the gradient as well as a point for us to be able to work out the equation. So the gradient we've already worked out here. And then the point, we're going to use then the point of contact. In this case, it would be given as x at P, y at P. And then you're going to substitute that into the straight line equation to find the equation of the tangent. Right. Let's look at an example. Remember the steps. Determine the equation of, or rather, the gradient of the radius. Work out the gradient of the tangent using the property. Use the equation of a straight line to determine, or rather use the standard equation of a straight line to substitute both the gradient of the tangent as well as the point of contact to find the equation of that particular tangent. However, grade 12s, remember you need the center to be able to work out the gradient of the radius. And in this case, we are given an equation that is not in standard form. The equation is not in standard form, which means that we cannot exclusively, if I were to draw a rough sketch of this, we don't know the coordinates of the center because the equation is not in standard form. However, we know the point of contact. This is just a rough sketch. The point of contact is 5 is to -6, which means that we need the coordinates of the center in order for us to be able to work out the gradient of the radius. Now, since the equation is not in standard form, we need to first write the equation in standard form, and after writing it in standard form, then we'll be able to determine the center, which will then lead us to the gradient of that particular radius. Right. Now, what we're going to do is we're going to then complete the square to write down the equation in standard form. Remember, when we complete the square, we group the x's on their own and the y variables on their own. So this would be x squared minus 4x plus y squared plus 10y. This is equals to -19. We move the constant to the right hand side. Now, in completing the square here, we get -4x. We take now the value of b. In this case, it's -4 divided by 2. That would give us 2. And then we square 2, we get 4. Plus y squared plus 10y. In this case, the value of b is 10. We take 10 divided by 2, which is then 5. If we square 5, then we get 25. Now, if we check, I've added 4 and 25 on the left. I'll do the same on the right. -19 plus 4 plus 25. Now, in doing so, I can be able to complete the square for x values of variables, complete the square for y variables as well. So through completion of the square, take the square root of the leading variable x, and then we take the sign of the middle term minus, we take the square root of the last term 2, and then that's squared. Plus, we do the same for y, square root of the leading variable, which is y, squared, we get y, and then we take the sign of the middle term, which is positive, and then we take the square root of the last term, which is 25. Square root of 25 is 5, and then we square the result, and this would be equals to, in this case, if we add -19 plus 4 plus 25, we get 10. We get 10. Now, it means that the center would be 2 is to -5. That would be the center, 2 is to minus 5. So if we have the center 2 is to minus 5, then we can work out the gradient of the radius. So the gradient of the radius in this case would be y2 minus y1 over x2 minus x1. If we look at these set of ordered pairs that we are given, we can take minus 6 minus minus 5, that is minus 6 plus 5 over 5 minus 2. 5 minus 2. This will then give us minus 6 plus 5 is minus 1 over 3. So this is minus 1 over 3. This is the gradient of the radius. So using the fact that the tangent is perpendicular to the radius, we can work out the gradient of the tangent. We know that m radius times m tangent is equals to minus 1, which means that m tangent would be equals to minus 1 divided by minus a third. So this would give us positive 3. So we have that the gradient of the tangent is positive 3. Remember, to get the equation of a line, we need a gradient and a point. In this case, we have the gradient and we have the point of contact given by 5 is to minus 6. So to find the equation, we can use y minus y1 is equals to m into x minus x1. Remember, you can also use y is equals to mx plus c. Right, we have that y minus, we use the point of contact, 5 is to minus 6, which means where we see x, we're going to put 5. Where we see x1, x1 is 5, y1 is minus 6. So where we see y1, we put minus 6. So we have y minus minus 6. That would be y plus 6 is equals to the gradient, which is 3, into x, the value of x minus x1. x1 in this case is given by 5. Now, if we simplify this, we're obviously going to obtain y is equals to, we apply distributive law to distribute the 3 on the right hand side into the bracket. So this is 3x minus 15 through distributive law. Then we transpose the 6 minus 6, and this simplifies to y is equals to 3x minus 15 minus 6 gives us minus 21. So we've successfully worked out the equation of a tangent. Right, let's review the steps again. First things first, you check whether the equation of the cycle is given in standard form. If it's in standard form, then you are going to be able to pick up the center and as well as the point of contact, which means that now if you have the center and the point of contact, you can be able to work out the gradient of the radius. And then from there, we know that the radius is perpendicular to the tangent, which means that the product of their gradients becomes minus 1. So you'll be able to work out the gradient of the tangent. Using the standard equation, you'll be able to then substitute the gradient as well as the point of contact to find the equation of a straight line. However, in our case, the equation was not given in standard form, so we needed to standardize the equation first so that we can get it in center and radius form, and then we can be able to pick up the center, hence be able to calculate the gradient of the radius. Right, moving on. The length of a tangent to a circle. Now, this is an interesting concept as well. We are interested in working out the length of a tangent. In order for us to be able to work out the length of a tangent, we need the following steps. Step 1, if the equation is not given in standard form, you need to write down that equation in standard form so that you'll be able to get the length of the radius. And then from there, you're going to use the external point that would be given so that you'll be able to work out the length of the hypotenuse and hence use Pythagoras to work out the length of that particular tangent. Now, if we can visualize this, if we have this tangent and we are given a point P, x at P, y at P, and then we are given the center. In this case, the center is A is to B. And then now, if we work out from the equation of the circle, if we work out the length of the radius, we know that the radius is perpendicular to the tangent. And if we can then construct a line here to visualize this, you can see that we have a right-angled triangle. Now we're going to work out the length of the radius from the equation, so we'll know this one. And then we use the given points, this point here and that point there, to work out the length of the hypotenuse. And hence we can use the Pythagoras Theorem to work out the length of that particular tangent. Right, those are the steps. Let's see how these steps can be applied in solving this particular problem. Right, given the equation of the circle, x squared plus y squared minus 4x plus 10y is equals to 7. With the tangent PQ touching the circle at P, if a point Q given by 8 is to 3 is the point on the tangent, determine the length of PQ. Now, in this case, the equation is not in standard form. So we need to write the equation in standard form first so that we can get the coordinates of the center as well as the length of the radius. Now, if we write down this equation in standard form, then it follows that x squared plus y squared, right? If we want to write it in standard form, we have to group the x's on their own. X squared minus 4x plus y squared plus 10y is equals to 7. Already the constant has been moved for us to the right hand side. So we complete the square for x. That would be x squared plus, or rather, x squared minus 4x plus, we take the value of b minus 4 divided by 2, which is minus 2 squared, we get 4, plus y squared plus 10y plus 10 divided by 2, which is 5 squared, that's 25. So we've added 4 and 25 on the left. We're going to add 4 and 25 on the right. So completing the square gives us x minus 2 all squared plus y plus 5 all squared is equals to 7 plus 4 plus 25, we get 36. Which means that r squared is equals to 36. R would be the square root of 36, which is 6. And the center in this case would be given by 2 is to minus 5. Now that you have the equation of the circle, you know the center 2 is to minus 5 as indicated on the diagram. You know the length of the radius, which is 6, which means that now we want to work out the length of the hypotenuse. We need to work out the length of the hypotenuse. In order to do that, we need the coordinates of the center as well as the coordinates of the external line, which means that if we want to work out the length of the hypotenuse, we can then say the hypotenuse in this diagram is given by QM. QM would be given by the square root of, we are using the distance or the length formula, x at Q minus x at M. In this case, that would be 8 minus 2 all squared plus y at Q minus y at M. That would be 3 plus 5 all squared. Now, in working that out, we get that the length of QM becomes 10. So we have 6, we have 10, which means that we are now left with the side PQ, which is the length of the tangent. In order for us to work out the length of the tangent in this case, we're going to be using the Pythagoras Theorem, right? Let me go back a bit. We worked out the length of the radius, that is 6, and we put it on the diagram. And then we worked out the length of QM that is 10, and we put it on the diagram as well. So we are looking for PQ now, which is the length of that particular tangent. We said we're going to use Pythagoras. So we know that our PQ, or rather from the Pythagoras theorem, the square on the hypotenuse QM squared is equals to PM squared plus PQ squared. This is from the Pythagoras theorem. Now moving on, what we can then do is we can then work out PQ, which would be the square root of QM, 10 squared, minus 6 squared. So 10 squared minus 6 squared gives us 8 units. So PQ would be given by 8 units. Right, moving on. Determine whether the point lies inside, outside, or on the circumference of the circle. This is not difficult to work with grade 12s. What you basically do is they'll give you the equation of a circle, and they'll give you a point of analysis. So that particular point is the point that we want to analyze, whether it lies inside our circle. We want to know if this is our circle. We want to know whether the point is inside, whether the point is on the circumference, or whether the point is outside. So you'll be given that particular point. In order for you to check whether it is inside, outside, or on the circumference, what you do is you take that point, you substitute it on the left-hand side. Remember, on the equation of the circle, you'd be given the left-hand side, x minus a all squared plus y minus b all squared is equals to r squared. So when you substitute on the left-hand side, the value that you're going to get, you compare it with the radius on the right-hand side. If the value is smaller than the radius, it means the point is inside. If the value is exactly the same as the radius, it means the point is on the circumference of the circle. If the value that you get is greater than the length of the square of the radius, or is greater than the right hand side, which is r squared, then you're going to say that the point should be outside that particular circle. Right, let's just do that through example 6. Determine whether the point lies inside, outside, or on the circle. So what we're going to do is we're going to work with the left hand side and the right hand side. So this would be our left hand side. What is it that we'll do here? We're going to take this point, because we are given the value of x and the value of y, substitute the point on the equation, and then after getting that value, we compare it with the right hand side. So we need to then compare. It is the comparison that is going to tell us whether the point lies inside, on the circumference, or outside. Remember what I said? I said if the value that you get on the left, when you compare it to the radius squared, in this case is 15. If you get the value that is less than 15 on the left hand side, you would say it's inside. If you get a value that is equals to 15, it's on the circumference. If you get a value that is bigger than 15, it is outside. So let's check now. We substitute. X in this case is 2 all squared plus y minus 9 all squared minus 8 into 2 plus 6 into minus 9. Now, if you simplify this, this is our left-hand side. If you simplify this, obviously this would be 4, this would be 81, this would be minus 16, and 8. 6 times 9, this case would give us minus 54. If we simplify this further, we're going to get that this is 4 plus 81 minus 16 minus 54. This gives us 15. So you can see that the left-hand side is exactly the same as the right-hand side. Because they're exactly the same, therefore the point lies on the circumference. The point lies on the circumference of that particular circle. And moving on, grade 12. I'm going to skip this activity for now because of time. If time permits, I'm going to come back to this and give it to you so that you work out whether the point lies inside, outside, or on the circumference. I want us to look at the next concept. In this case, is the relationship between circles. The relationship between circles. Now, when we look at the relationship between circles, we want to find out whether the two circles that will be given, we want to find out whether they do not touch, whether they touch externally, whether they touch internally in 2 points or 1 point, or whether the one circle is inside the other. That is basically what we want to determine. So in order for us to determine the relationship between those two circles, we're going to determine the distance between their centers. So if it's circle 1 on the left, circle 2 on the right, we determine the distance between their centers. After determining the distance between their centers, you compare that with the sum and the difference of their radii. I explain again. You get the distance between them, between their centers, so to say, and then from there, you compare that with the sum as well as the difference of their radii. Right. I present to you 6 cases in which we're going to try and analyze this concept. Case 1, I have circles that do not intersect, one away from the other. So I'll draw those circles. Now, the center of the bigger circle, I call that C1. The center of the smaller circle, I call that C2. The radius of the bigger circle, I'll call that capital R. The radius of a smaller circle, call that small letter r. Then after that, you need to compare that with the distance between their centers. That is D. Remember, if you have the coordinates of the centers, you can use the distance formula to determine that. To determine R, big letter R and small letter r, obviously you'll get that from the standard equation of the circle. Right, in this case, you can see that when you compare D and the sum of the radii, you can see that D, the distance D, is much bigger than R plus R. So if you are to analyze two circles and get that the value of D is greater than the sum of the radii, then you're going to say that circles do not touch or they do not intersect. Because if you check here, there is that extra space which makes the distance bigger. Right, moving on to case 2. Right, what I'm going to do is I started with the circles at a distance apart. I'm going to move them closer together. Now, if I move these two closer together so that they touch externally, I'm going to identify center 1 for the bigger circle, center 2 for the smaller circle. Obviously, the radius of the bigger circle is R, the radius of the smaller circle, small letter r. The distance between the centers, D. If you check now in this diagram, you can see that the distance between the centers D is exactly equals to R plus R. The distance is exactly equals to the sum of the radii. So we're going to say that therefore circles touch externally. The circles touch externally because the distance D is equals to the sum of the radii. Moving on. Now I started with them at a distance apart. Then they are now touching. Going to move them much closer together so that there is an overlap or an intersection. Now, if I do that, this is what I'm going to get. So this is the center C1, and this is the center C2. This would be R for the bigger circle, and then this would be small letter r for the smaller circle. Now, if you check here, the distance d, if you check r plus r, you can see that there is an overlap or an intersection. So there's a part there that is going to be added twice. As a result, we get that d should be less than r plus r. The value of d is less than the sum of the radii, or the sum of the radii is greater than d. However, if we are to analyze this further, we can see that, however, that value of d is greater than the difference r minus r. So we get this compound inequality in this case. Now, if this condition holds, then we're going to say that the circles intersect at 2 points. And if they intersect at 2 points, it means you'll get 2 points of intersection. And you can be able to work out a line of intersection because these two intersect on 2 points. If those 2 points are to be joined together, you can be able to work out that line of intersection, which would then be an equation of a straight line. Right, circles touching internally, I move them closer again, but now I have that the small circle touches the bigger one internally. In this case, if this is C1 and this is C2, can see that this is R, the bigger R for the bigger circle, and this is small letter r for the smaller circle. Now, if you compare that with the distance d, you can see that if you are to take the length of r, the bigger length of r, and subtract the smaller length of r, if you are to then take this away, you'll be left with just this distance. And that is exactly equals to the distance d underneath. I repeat, if you take this line, small letter r, and remove it from the bigger line r, you'll find that what remains is exactly equals to d. So we say that now the value of d is exactly equals to r minus r. If that's the case, then we're going to say circles touch internally. Circles touch internally. Right, moving right along. Circles that do not intersect, one inside the other but no common center. If we have this bigger circle here and we have that the smaller circle is inside the bigger circle but does not touch it, if we work out the center C1 and the length of the radius r for the bigger circle, we can do the same for the smaller circle as well. We can work out the center C2 and the radius small letter r. Now, if we compare that with the distance between their centers, you can see here that even if you are to subtract, if this is the line r, and you are to subtract this part here, there will be this portion that would be left and that portion that would be left. So those portions they add up to a value that is bigger than d. So you can see that here d is less than r minus r. So if you find that d is less than r minus r, then you're going to say that circles do not touch. However, the smaller circle is found inside the bigger one. Right, moving on to the last case. We're talking concentric circles. In lower grades, you learned that if circles are concentric, then they share a common center. That is lower grade knowledge. If two circles are concentric, or two or more circles are concentric, then they share a common center, or they have the same center. So if C1 and C2 is the same, it means that you cannot determine the distance d, or if you work it out, you find that d is equals to 0. So we can say that now, therefore, the circles are concentric. Yes, they do not touch. They do not touch, but the smaller circle is inside the bigger one and shares the same center as the bigger circle. Right, that's the knowledge that we've gathered for now. Those are the 6 cases to determine the relationship between two circles. Now we can summarize that relationship through a number line. This number line works in this way. I have the value of d being big at the side. As d grows bigger, starting from 0 to a bigger value, then I'm going to analyze it from d being bigger. If you check from d being bigger, you can find that d is greater than r plus r. They do not intersect. If d is equal to r plus r, they touch externally. If d is between r minus r and r plus r, that compound inequality, then the circles intersect at 2 points. If d is equal to r minus r, they touch internally. If d is less than r minus r, in this case, we're going to say the smaller circle is inside the bigger circle, but they do not have the common center. Now, there's one case that is not covered here. This is case 1, 2, 3, 4, 5. Case 6 occurs when d is exactly equals to 0. What happens when d is exactly equals to 0? We have that the two circles are concentric. So this is the 6th case. So that is the analysis of the relationship between circles, grade 12. Now that we have looked at the theory that governs the relationship, it is much proper that we now look at the algebraic properties so that we can find out how we can determine whether they intersect or they do not intersect, or they intersect at one point or in two distinct points. We need to know how to work it out in problem solving. Right, let us do that through these particular steps. Step 1, you determine the distance between the centers. Remember, you need to know the centers first. And then step 2, you work out the sum of the radii and the difference of the radii. Then you compare the distance with the sum and the difference of the radii, and then you will know from any of the 6 cases which case will be applicable. Yeah. Right, moving on, we are looking at example 7. Show that we are given two circles. Show that the circles intersect each other at 2 points. Now, if you check, one of the circles is not given in standard form. Remember, we need the center of the first, the center of the second, so that we can get the distance between the centers. So we don't have the center of the first circle. The center of the second circle, that is center 2. Center 2 in this case is given by 4:6. And then we have that the length of the radius is given by square root 26. However, we don't have the liberty of doing the same for circle 1 because this equation is not in standard form. So we're going to quickly convert it to standard form. Remember, we group the x's on their own, 8x, and then plus y squared plus 4y transpose the 38, completing the square here, x squared plus 8x, 8 divided by 2, that is 4, then this would be at 16, plus y squared plus 4y. Obviously, 4 divided by 2, that would be 2. If you square that, you get 4. This is equals to, we've added 16 and 4, so we'd have 38 plus 16 plus 4. When we quickly work that out, when completing the square for the first and completing the square for the second, you take the square root of the first term, which is x, and then you take the sign of the middle term, that is positive, take the square root of the last term is 16, square root 16 gives us 4 squared, plus you do the same for y, plus 2 all squared. Then you have 38 plus 16 plus 4, which we need to check in the calculator. 38 plus 16 plus 4. Obviously 38, 16 plus 4, that's 20, plus 38, that should be 58. Now, moving on with this, now we can conclude that center 2, or rather center 1, sorry, is given by minus 4 is to minus 2. And the length of the radius is given by square root 58. Which means that now we can be able to work out, now the sum of the radii, or rather, first the distance of the centers. What would be D in this case? D would be between these two centers, center 1 and center 2. So D would be the square root of 4 minus 4, 4 minus minus 4, that is 4 plus 4 all squared, plus 6 plus 2 all squared. This simplifies to 8 root 2, which we approximate to 11,31. That is the distance. I've worked out the two centers. I now know the distance between the centers. Now I'm going to work out the sum of the radii, r plus r. In this case, my r plus r would be square root 58 plus square root 26. If you add the two, you're going to get that this is 12,71. And then if we work out r minus r, the difference of the radii, then you're going to get square root 58 minus square root 26. This would then give us a value 2,52. Now, if you check here, if you are to compare D with r plus r and r minus r, what do you obtain? You obtain that D is greater than r minus r. D is 11,31. 11,31 is bigger than 2,52. However, D is less than r plus r. So we've showed that the circles intersect at 2 points. So therefore, circles intersect at 2 points. Right. Repeating what we did, we worked out r plus r, r minus r, and the distance between the radii. Right. The second question, since we found out that these circles intersect twice, they want us to work out the line of intersection, or to show that they intersect along the line y is equals to minus x plus 4. Right. Now, in order to do that, we need to solve these two circle equations simultaneously. Now, remember in grade 10, you learned the method of elimination. How and when do you use the method of elimination? You use the method of elimination if both the equations are in the same order. Like in grade 10, you worked with linear equations. Both of the equations that you were solving were linear, so we used elimination. But in grade 11, we used the method of elimination. In grade 11, we use substitution because one equation is linear and the other one is quadratic. So the order of these circles is the same. So the first thing that we're going to do is we work out we write this circle in this form. Now, if we do that, we then have this as x squared minus 4x if we open the first bracket, no, minus 8x, and then plus 16 plus y squared minus twice the product, minus 6y times 2 is minus 12y plus 36 is equals to 26. Now, moving on with that, we will have that this is x squared minus 8x plus y squared minus 12y is equals to, we transpose the 36 and the 16 to the right hand side, minus 16 minus 36, we get negative 26. So we've rewritten the second equation in terms of non-standard form. Now, from there, we are going to then use the method of elimination to solve the two equations. So I'll write the first equation, x squared plus y squared plus 8x plus 4y minus 38 is equals to 0. The second equation, that's x squared plus y squared, if we rearrange x plus y, and then minus 8x minus 12y. If we transpose that 26, that would be plus 26 is 0. So if you check these two equations, they are of the same order. So we can solve the two simultaneously. Now, by using elimination. So through elimination, I can subtract equation 1, equation 2. I can say 1 minus 2. If I have equation 1 minus 2, the x and the x gives 0, the y and the y gives 0. This would give us 16x. And then 4 minus 12, that would be 16y. And then we'd have 38 minus 26. That should give us minus 38 minus 26. That would give us minus 64 is equals to 0. Now, if we are to write this in standard form, we'll get that 16y is equals to minus 16x plus 64. Dividing by 16, we get y is equals to minus x plus 4, which means that we've showed that the line of intersection in this case is minus x plus 4. So what did we do to these two circles? We took the one that was in standard form, we converted it back to the form that is non-standard, and then from there we use the method of elimination to work out the equation of the line of intersection. Right. Grade 12, that's the time that we have for today. Thank you for tuning into the lesson. Remember to sanitize, wear your mask, and practice mathematics. Bye-bye.